Day 95 Notes, Advanced Algebra 2. Today we are working on a review for tomorrow's quiz, and the review that you're working through today is done on Angel, and the quiz tomorrow will be done on Angel, so they will look very, very similar to one another. Let's talk about these sample problems here. It's a multiple choice problem here for number one. We've been asked to identify the domain and range of this relation. Now the thing that you have to remember here is that domain is our input values, and we also call those our x values. The range are the output values, or the y values. So when we have domain and range given to us here in a table, it's very easy to identify. We're looking for domain values, the list of these numbers, 5, 6, 0, and 10. And that doesn't really display that clearly. This should be a negative 10. And then our range values, our outputs are 11, 13, 0, and negative 19. So we should get in the habit of listing these in order from least to greatest. And if we do so with the domain values, we start with negative 10. We move to 0, then 5, and then 6. So it looks like option C is our best choice so far. Let's double check to make sure the range matches as well. That should be negative 19, 0, 11, and 13. And that's what we have. So option C looks good for number one. Number two, to determine whether a relation is a function, we must remember that each input must have exactly one output. So as long as that's the case for this list of numbers, then we will be working with a function here instead of just a relation. When we have a table that's oriented sideways like this, our input is on the upper line and our output is on the lower line. So if I look at each of these inputs, we have 11, 12, 13, 14, 15, and 16. Do any of those inputs map to more than one output? Do any of them map to no outputs? That's what we're asking ourselves here, and that's what we're checking. And as it turns out, they don't. Each input does map to exactly one output, so we're in good shape. Yes, this is a function. Number three, use the vertical line test to determine whether a relation is a function. If not, identify 2 points a vertical line would pass through. Well, remember the vertical line test, or VLT, says that if we draw a vertical line through a graph, that vertical line must cross the graph only one time. It must cross exactly one time. It's very similar to the definition that we've given for our functions up here. So if I can draw a vertical line, such as this vertical line right here, these 2 points have touched the graph and that vertical line. So no, this is not a function. Now, had there been more options here, we'd have to be very careful about which points that we identify, but this is the only option for us here. Option B only gives us one choice, and it's showing us that 0, 4, which is this point, and 0, negative 4 is that point. What they're recommending us to take a look at is the vertical line that falls through those 2 points. And so there's the vertical line that they used for their test, and these are the 2 points that violated the vertical line test. But it's okay if you use any other vertical line. So in my example, I used a vertical line somewhere over here, and that's possible. You can use a vertical line over here, or again, anywhere in between. Any one of those indicates that this graph does not pass the vertical line test. Therefore, it is not a function. Question 4 is a bit of an unusual one. It's not one that we've practiced much of, but I'm sure you can work your way through it. The question asks, which is an element of the range of the graphed function. So we know we're dealing with a function here. It would pass the vertical line test. None of these vertical lines touch the graph more than one time. So we are dealing with a function. We're being asked about the range, however. So the range is associated with the y values. And what I want you to remember is that the y values come from any coordinate that can be picked from this graph. So if I just choose a few here, I've got the coordinate 0, -2. Here, this is supposed to be, oh, I don't know, it looks like 1 and -2.3. That's just a guess. That's approximately where we are. This point here is 2, -3, and we might have 3, -4 in this location, and so on. What I need you to focus on are the y values for each of these points. If I went to this side of the equation and started listing those same points as well, they would be exactly the same, except our x value has changed. Instead of being at 1, -2.3, this point is at -1, -2.3. And this one appears to be at -2, -3. And this one appears to be at -3, -4. So each of these points, again, represent solutions or parts of the function. What are acceptable range values for this function? What types of numbers are we seeing for these y values? Could the range have been -3? Sure, it looks like it. In fact, we found one here that had a range value of -3. Could it be 0? Are there any range values equal to 0, -1, or 1? And the answer is no for those, because nowhere does this graph have a coordinate with a y value of 0. If we had a y coordinate with a value of 0, that would have been somewhere along this line here. Or if the y value of the coordinate was a -1, that would have been up here. And if the y value had a coordinate of +1, we'd be up here. And none of this graph, none of the coordinates from this graph will reach that high in our range value. So again, range, as we discussed on the very first day of this section, is how tall the graph can get, or how high the graph can get on the y-axis. Its limit is right here at -2. It can't get any higher than that. -3 is the only one in that list, so that's why we're going with A for an answer to number 4. Number 5, we need to evaluate this function at -1. So you'll remember from class that to evaluate f of -1, we need to change the letter x to a -1. So we'll change x to -1 and put it inside parentheses here. Multiply those two to make -2, and -2 plus 9 is -7. Oops, I need to be careful with my math here. -2 plus 9 is +7. Looks like C is the choice to go with for number 5. Number 6 is a multiple choice question and asks us to graph the function shown here. And it's very similar to the function that we had above. But since it's a multiple choice, we have several choices to choose from. Now, if you're familiar with linear functions and their properties, you may recognize that this looks like the function y equals mx plus b. And if you recognize the m value and the b value and can graph from there, then I would encourage you to do so. If you don't remember that, then what I do need to remind you is our discussion that we had, again, towards the beginning of this unit about graphing functions. When we graph functions, we select our own input values, -2, -1, 0, 1, and 2. I like using these because they give us a good representation of the graph around the y-axis. Then we would calculate our output values from each of these input values. So if x was -2, the function result would have been -2 times -2, well that's a +4, plus 1. That makes 5. For x equals -1, I need -2 times -1. That's +2. And positive 2 plus 1 is 3. Negative 2 times 0 plus 1 is 1. We're starting to see the pattern that forms here. My next number should be negative 1 and then negative 3. Each of these range values decreases by 2 each time. Now, if I graph these, and I'll just sketch a graph here, at negative 2, I should be 5 units in the air. At negative 1, I should be 3 units in the air. At 0, I should be 1. At 1 unit, I should be 1 unit below the x-axis. And at 2 units, 2 to the right of the origin, I should be down 3 from the x-axis. And so what I'm looking for is a graph that follows these coordinates. That's not going to be the case for A. It's not going to be the case for B. C looks kind of close, but it doesn't look like our coordinates match. This 0 should have been here, and at 1 we should have been here at negative 1. So C doesn't work. It looks like D is our best choice. These points all align with the sample points that we created in our table. D is a good answer. And number 7 is another one of the questions that we haven't practiced much in class, but I think you can work your way through it, especially after seeing this practice problem. We have a commercial jet that travels from Los Angeles to Chicago, and it averages 350 miles per hour. The air distance from Los Angeles to Chicago is 1,745 miles. So this jet has to travel 1,745 miles between those two cities. Our job is to write a function to represent the distance remaining on the trip after takeoff, t hours after takeoff. Let's just talk about this for a second. When our time is 0, or at the beginning of our trip, before we even take off, the result is going to be 1,745. There are 1,745 miles left before we go anywhere. Now, after 1 hour, we might think that the distance decreases by 350 miles. And that comes out to be 1,395 miles left. And then the distance after 2 hours is another 350 miles less than this. And so that leaves us with 1,045 miles left to go. And this pattern would continue. So in your mind, you have to be thinking which of these rules will give us the same results that we're seeing over here on the right-hand side. Now, we could guess and check. We could complete the calculation for each option here. That's a fine test-taking strategy if you have enough time in the class. What I might recommend, though, is you thinking about what's happening with the calculations here. We're starting with 1,745, and we're reducing the amount of distance left after each hour. And to reduce those, we have to subtract a number from that. And as soon as you start thinking of an equation assembled this way, it looks like C presents itself as a final and correct answer. But we're not quite done. We should double check this. If we think that 350 times t is the remaining portion of the calculation, we should check at least 1 or 2 of these numbers to verify that this is correct. So if I use this and think of the equation evaluated at 0, this would be 1,745 minus 350 times 0. Now that does equal 1,745, so we're in good shape there. Let's check D of 1. 1,745 minus 350 times 1. Well, that would be equal to 1,745 minus 350, and that does equal 1,395. That's a good check. And if we go one more time, 1,745 minus 350 times 2, well, that's 1,745 minus 700, and that does equal 1,045. And I think after checking 3 of those three of those results, I'm pretty satisfied with this solution. So therefore, I would say that C is your best choice. Please let me know if you have any questions regarding this sample quiz. I'd be happy to discuss them with you while you are practicing for the quiz tomorrow.